I've been sent in this question by a viewer, and it has to do with Year 12 probability. It goes like this. Alan buys 4 tickets in a raffle, in which 100 tickets are sold altogether. There are 2 prizes in the raffle. Find the probability that... Now, this person's interested in part C. Find the probability that Alan will win 1 prize. And I assume that means 1 prize only, because part E says at least 1 prize. So this would be 1 prize or 2 prizes. So I guess that means 1 prize and 1 prize alone. I need help with 12C. I don't know how else to do the question without the use of binomial probability. Thank you. Okay, now, that interests me because this is a case, this kind of question is an example where binomial probability is actually a great way to solve this question. I think it's a little more succinct and elegant as a solution, but as you maybe, this appears in a 2-unit exam or something like that, this question can be done without binomial probability. So I'm going to show you 2 ways to solve it. I'll solve it without binomial probability, and then I'll solve it with binomial probability. Okay, so let's get this out of the way, get some working paper. Okay, so let's think about this. What do we know? We've got Alan, who's bought 4 tickets, right? So that's kind of where he's going to get his possibility for winning a prize. Altogether, there's 100 tickets, and I've got 2 prizes. Okay, so let's think about this option. How would he get 1 prize? How many ways would be possible for him to get 1 prize? Well, since he's got 4 tickets, right, I can think about each individual ticket and their probabilities for getting a prize or not getting a prize. Okay, so for instance, let's think about that first ticket. What's the probability that that gets a prize? Well, since there are 100 tickets in total, and there are 2 prizes, okay, that means that the probability of getting the first ticket, getting a prize out of the 4, is 2 out of 100, okay? Right, now, if the first ticket has gotten a prize, then if he only has 1 prize, that means his other 3 tickets don't get prizes, okay? Well, let's consider what's the probability of those, and because these events that I'm about to describe, they happen simultaneously with the first ticket, because he's got all 4 tickets. I'm going to multiply these together, right? Okay, now, what's happened? He's going to get no prize for this next ticket, okay? Well, how many tickets are left which have no prizes? Well, he hasn't taken any of them out. And if there are 2 prizes, that means there are 98 which have no prize. Right? So that means the probability of picking up a ticket with no prize after he's gotten a ticket with a prize is 98 out of... Now, it's not going to be 98 out of 100, because there aren't 100 tickets anymore. He's already drawn 1. So it's going to be 98 out of 99. Okay? Alright. That's the first 2 tickets. The third ticket is also not going to get a prize. Now, because he's taken out one of the non-prize tickets, there will be 97 left. And the total number of tickets, because he's pulled out 2, will be 98. And you can see the pattern's going to continue on for his 4th and final ticket. There will be 96 non-prize tickets left. And he's pulling them out of a pool of 97. Okay, so what have we got here? This is... a prize, not a prize, not a prize, not a prize. So here's one possible way of getting 1 prize and 1 prize only. But it's not the only way, right? His first ticket might not get the prize. It might be the second ticket that gets the prize, right? So instead of this kind of arrangement, I might have the first ticket getting no prize, the second one getting the prize, and then the other 2 being the same. Now let's just consider this option and compare it to this one, okay? What's the probability of the first ticket not having a prize, okay? Well, it's kind of like this one, but flipped around, right? In fact, it's the complement. This event is the complement of this event, right? Because to not get a prize, well, there's 98 different ways to do that, 98 different no prize tickets, and there's 100 left at the beginning before any tickets have been chosen, right? Alright, now that we get to the next one, there's a prize ticket. Well, there's 2, but again, 1 ticket's been taken out, so there are only 99 left. And then, the rest of it proceeds as usual, because how many no prize tickets are left after 1's been taken out? There will be 97. And how many tickets are there in total? 98. And then off in the end, you've got 96 and then 97 total, right? Okay, now compare these two, right? The first thing you'll notice is that the denominators are the same. 100, 99, 98, 97, okay? And that's because in each case, as you consider the first, second, third, and fourth ticket, you're picking from the same size pool, right? There's always 100 tickets to begin with, and then there's always 99, 98, and the last ticket, there will always be 97 to choose from. Now let's have a look at the numerators. The numerators are also the same, but they're in different order. And the different order reflects where the prize comes in, okay? But it's always going to be the same set of, favorable outcomes, right? There's always a 2 that corresponds to one of the prizes, right? There's always the 98, the 97, and the 96, okay? It's just that the order is switched around because there's a no prize first rather than second, okay? So you can see this is my my first way of winning just one prize. Here's my second way. Well, there's 2 more, right? There's this one having the prize not in the second slot but in the third one, so that'd be N, no prize, no prize, prize, no prize, okay? Then there's a fourth one having the prize right at the very end. No, 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 and then a prize. Now you can see that the probabilities for all of these are going to be the same, right? So you can work out what one of these is, and then you can multiply it by 4, right? So just before I move on from that, these 4 possibilities, we've just sort of thought that out logically to work out that there's going to be these 4 options, but you can draw, if you like, a probability tree to arrive at the same kind of conclusion. And for a question like this where it's got multiple parts, you know, looking at this, you're going to have to answer the same kinds of questions for the same scenario, but it's just slightly different adjustments, right? So you can draw a probability tree. It looks something like this, okay? And you can see the options that we're after. There is the first prize, okay? Sorry, the prize on the first ticket. There's the one on the second ticket, on the third, and the fourth. Okay, and if you worked out what the probability on each of these branches of the tree is, they're going to correspond to these fractions. Okay, right. So what's the actual answer then? I've got these 4 different ways, and these are independent of each other. So I'm going to add them up. I'm going to have whatever this is and multiply it by 4. Okay, because all 4 of these ought to be the same. So I'm going to get 4 by 2 on 100. 98 on 99, 97 on 98, 96 on 97. Okay, that's actually going to be my probability. And my calculator is telling me that that should be equal to, excuse me, 64 on 825. So there's your answer. There's the probability of getting one prize and one prize only. Now, I promised, excuse me, that I'd show you how to solve this without using, you know, this kind of logical method. What if you were a 3-unit student and you could do binomial probability? Well, again, let's come back to this piece of information at the top, which is that we got 4 tickets. There are 2 prizes and 98 which have no prize, right? So, how am I going to work this out? Well, up the top, my favorable outcomes, what I'm really after is that from these set of 2 prizes, what I really want is one of those. Okay, so out of this team, if you like, I want to pick 1, and then from this group of 98, I want to pick 3, right? Because I have to have 4 tickets in total, and I don't care which ones they are or what order they're in. I just want 1 of these and 3 of these. Okay, and you know, what's the total number of of ways to do that? Well, out of your 100, you're picking any 4, right? Well, 4 tickets, okay? So what's the probability in total? If I would express this in binomial terms, the probability would be, out of these 2, I want to pick 1. So I would say 2, choose 1, right? But I also have to pick my other 3 tickets, and there are 98 different ones I could choose from, so it's 98, choose 3. Okay. Now these are the favorable outcomes. These are the ones I want, right? I have to work out what the total number of outcomes is, and that gives me a probability, right? Well, the total number of outcomes comes from the 100. Out of that 100, I have to choose 4. Okay. Now, you could plug that into your calculator and you could get the answer out. But just for the sake of it and to illustrate how these really are doing the same thing, let's go ahead and evaluate, well, what's this choose notation about, NCR? What does it actually give us in terms of factorials and that kind of thing? Well, 2 choose 1, right? What's that? Well, that's 2 factorial on 1 factorial, 1 factorial. Yeah? What's this 98 choose 3? Well, that's going to be 98 factorial divided by 3 factorial 95 factorial. Okay? So there's one NCR, there's the other one. What's on the denominator? Well, same kind of pattern. You're going to get 100 factorial on 4 factorial 96. Okay, make sure you got your brackets in there because when you got fractions and fractions, it can be confusing. Okay, now let's evaluate some of this, right? 1 factorial, they're just 1, so this denominator doesn't matter. 2 factorial is just 2 by 1, so out the front I've got a 2. Okay, what are we going to get here? Well, 98 factorial divided by 95 factorial. This is 98 by 97 by 96 by 95 and so on. But because I'm dividing by 95 factorial, all of the terms after 95, they disappear, right? So all I'm left with is 98, 97, 96, and all the other ones have been divided through by this 95 factorial, okay? And then I've got this 3 factorial on the bottom. I'll leave that there for a second. What do I have on the bottom? In just the same way that the 95 factorial eliminated a whole bunch of terms from the 98, this 96 factorial will eliminate a whole bunch of terms off the 100 factorial. Namely, it'll leave me with 100, 98, 99, 98, 97, and then all the rest will have been divided through by that. That's divided by 4 factorial. Okay, now, this is a fraction on a fraction, so to simplify it a little bit, let's get that 4 out from there. That should really go onto the numerator, right? Or the 4 factorial, rather. So I should have 2 by 4 factorial by 98, 97, 96 divided by 3 factorial. And that leaves me with these numbers down the bottom. What was left of the 100 factorial. But you can see this 4 factorial and this 3 factorial, that's 4 by 3 by 2 by 1. That's 3 by 2 by 1. So when I divide through, all I'm left with is a 4, right? So that's 2 by 4 by 98, 97, 96. All over these 4 terms. Okay, now, does that look familiar? I hope so. The order is slightly different, but it's exactly the same thing we worked out before. You see you've got the 4 and the 2 out the front there, right? And then your 98, 97, 96, they follow, and your denominator is exactly the same. This is the same fraction. This is still 64 on 825. Okay? So that's how I'd go about solving it if I could use binomial probability. And it's worth mentioning that if you can, you just go here, and then your calculator will evaluate that, and you can more or less go straight there. Unless there's, many marks devoted to this question, and maybe you want to evaluate the factorials. If you are in 2-unit, and you're not supposed to know about binomial probability, you still can use this method if you understand it. But if you're not that confident with it, then go about it this way. It's still just as logical, and it doesn't take that much more time to work out.